It's hard for me to say I'm excited about storage without thinking about the applications. And one of my favorite applications for storage technology has, of course, been video games. So why should we talk about video games? Well, playing games is obviously fun. A lot of people fall into this misconception that the video game industry is a lot of fun. I've got to confess, making games is real work. It's horrible. It's taxing, it's grueling, and it really took a lot of the joy out of playing games for me. My first week in industry, I worked as a play tester, and that first week I had dreams of playing games for a living and getting paid money to do it, and that week I had nightmares. So it's turned a source of entertainment into a source of frustration and work for me for decades. Another reason we should talk about games is there's big money and there's steady growth in the industry. Customers keep buying video games. No matter what we do to mess things up, they keep coming back. And I also see some real industry growth and opportunity for meeting some unmet needs here. So how big is the market? Got a little logarithmic chart here. It's really hard to say how big the market is because we've got a number of different measures. For a long time we were talking about just arcade games. Arcade games, we started with a quarter. The games started with just pumping quarters into an arcade box on a bar top here in Sunnyvale. And immediately, we're at about $40 million in quarters. Now, try and imagine all those coins. Then pretty soon we had a home game, and that allowed us to build a retail market on top of that. And a combined worldwide market, that seems to be the figure that we're using more these days. And note, this is also a logarithmic graph. I tend to use logarithms to deal with these very, very large numbers. So we're going from about $40 million there in the early 1970s, and here we are about 50 years later at about $134 billion. So it's been neck and neck with the film industry for a while. All these slides, by the way, are available online. Yes, sir. Storage is the canvas upon which us game developers paint. For a long time, we had to deal with issues of, how much processing power we have in the box versus how much storage we have in the box. If we don't have a whole lot of processing in the box, we have to pre-process a lot of our images, our video, our audio, and we're just playing it back through page flipping. When we get into a lot more storage, we can do that. Once we get a little bit more processing in the box, we don't have to rely so much on storage, and it's been a little bit of back and forth over the years. In Silicon Valley, we are in the business of selling the future. I want to point out, it's not necessarily inventing the future here, it's selling. Video games didn't really start here in Silicon Valley so much as we hijacked the idea and popularized it and marketed it. One of the phrases that stuck with me over the last several decades is, I know of no way of judging the future but by the past. So let's take a look at a quick history of video games. In the 1920s, a fellow named Philo T. Farnsworth and his wife Pem, they invented electronic television. Philo Farnsworth came from northern Utah, had this idea for rasterizing an image and presenting that on a cathode ray tube. Came out here to California, and in 1927, they were living right here in San Francisco when that patent was issued. Then in the late 50s, we had a fellow named William Higginbottom who created an oscilloscope-based game called Tennis for Two. And that was just logic and a lot of analog circuits there. But I want to point out, it was an interesting idea, but few people owned telescopes. One of the key ideas here is we built on an installed base of televisions. And that idea of installed base is useful for some other industries. So this is a special year, so I want to just give you a quick vignette about something 50 years ago. So Philo Farnsworth's widow, Pem, was interviewed, and the interviewer asks, okay, the image dissector tube that Farnsworth created, it was used to send shots back from the moon toward the Earth. She says, yeah, right, okay. What did Phil think of that? We were watching it, and when Neil Armstrong landed on the moon, Phil turned to me and said, Pam, this has made it all worthwhile. Before then, he wasn't so sure. So, getting into our quick history of video games, Ralph Baer invented the video game. He was really working for a government contractor, created this Magnavox the Magnavox Odyssey. And that was kind of an interesting system. You could have these little cards that you could plug in, and that changed the behavior a little bit. Didn't really change the program of the game so much as just the hardwired behavior. Ultimately, Atari, they were trying to integrate systems that they saw in computers. Not really successful. They saw this Odyssey and said, hey, let's create this simple game, something that is really easy to wrap your head around, understand the rules. And they created Pong, tested it out in this local bar, and it worked well. They got a call from the bar operator here, and they said, oh, okay, this darn thing stopped working. They came in. It only stopped working because the coin box was so full of quarters. So they knew they had a hit. Started producing these things, and it was wonderful. They also built an ASIC to make a home game and marketed that through Sears. Nobody had an idea how to market video games at the time, so they wound up marketing this through Sears' sports department. So you go down there with your footballs and your basketballs, and here's this little thing that allows you to play basically a little sports game on the television. In the 1970s, we also had microprocessors invented. Started off with Intel and the 4-bit 4004 processor, the 8-bit 8008. Fairchild had this thing called the F8. Now that was interesting because Fairchild Semiconductor and Cameron Instrument Company, they created this video game box that you could shove a ROM cartridge into. They had chip on-board cartridges there, and this was 1976. This was new stuff. They put their F8 processor into there, and that was great. The year later, Atari comes along and does something similar. You know, again, not really inventing so much as copying, but they created their Atari video game system, the video computer system, later known as the Atari 2600. So this started off distributing video games on ROM cartridges, and if you were rich enough, you could get it on, you could get your programs on audio cassette, 5 1/4 inch floppy disks, and if you had the RAM that you could put it into, that's the way that we distributed games. It's also interesting to note that at the end of the 1970s already, Mattel had this system that had a 16-bit CPU in there, and that really was a popular machine for a little while. In the 1980s, something that really happened there was RAM was so expensive, but RAM got cheap. One thing that also happened to us is the 1983 North American video game crash. And this is something that we really have to confess to, because there was such a flood of these low-quality games hitting the market that it really did the industry a lot of damage. And what Nintendo did was interesting. They saw what was happening in 1983, and in the mid-'80s, they introduced their Nintendo Entertainment System. And that included the Nintendo seal of quality on all the cartridges that were published for that machine, and to enforce that they had control over the cartridges that were played on that machine, they put a couple of security chips in there, one on the cartridge and one on the motherboard. They did a little handshake there, and it was because of the Copyright Act of 1976 that went into effect the following year, that they were able to protect that particular mechanism. There was one company that tried to circumvent that and failed miserably, at least in the courts. So getting off of ROM cartridges, we had the idea that we could take 5 1/4 inch discs, 3 1/2 inch discs, especially for computer games, But once the games got bigger and bigger, you really needed to have a hard disk drive and able to play these games because you didn't want to swap the disks all the time. Interestingly enough, Sega was able to really market its 16-bit superiority. Here they are about a decade after Mattel with a 16-bit processor, and that was their claim to fame. 1990s, this was my favorite decade. Nintendo, they partnered with Sony to build the Super Nintendo Entertainment System, the SNES. Sony created the sound module inside of the Nintendo. We were looking at having an add-on CD-ROM mechanism, but CD-ROM was still a new technology. It was expensive. To add a CD-ROM drive to computers, an internal drive would cost $800 or $1,000 for an external. Years later, they partnered with Silicon Graphics to create the Nintendo 64. Pretty much all the great chips inside there were from Silicon Graphics and their semiconductor company that they purchased in 1993, MIPS. And that created the Nintendo 64. And they also did something interesting in the arcades. They created this game called Killer Instinct, and this was the first time I'd seen a hard disk drive mounted in an arcade game. Back in 1989, I was doing something similar for a point-of-sale terminal, but nothing on the grand scale that Nintendo did. Sony's relationship with Nintendo got a little bit heated here, especially with the Super Nintendo. Sony started seeing a lot of the money that Nintendo was making and wanted to get into that particular market. So late 94, early 95, Sony comes out with the Sony PlayStation and really makes the CD-ROM drive affordable. So that takes it down from an $800 unit that you put in your PC to a $300 unit. You could go down to Walmart. Walmart was actually selling them a little below cost because they knew that when you get somebody into the store, they're going to buy some games, and that's where they were making their margins. So they were already playing the razors and razor blades game there. When we get into the 2000s, to me this gets a little less interesting because we're getting into areas where we see a computer hidden into a box, disguised as a video game. We saw that a little bit in the 1980s with Atari rehashing their computer line, just dressing them up as video game systems, and that was done a few times with very limited success. Xbox, of course, took off. Optical discs, they get more density in layers. You go to a DVD-ROM, you're adding a second layer. Once we get into about 2006, we're working on Blu-ray discs, so that adds 4 layers capacity. We can go up to 100 gigabytes on that Blu-ray disc, and they're really cheap to distribute. Hard disk drives and networking, together they enable people to download their own games, and that's really changed a lot of distribution. But there's been some backlash against that as well. A certain segment of the gaming community, they actually want to have that physical disc that they can hold and keep and collect and trade. And I found that in the following decade. One of the really interesting things that happened in the 2000s was that Nintendo adopted these electromechanical systems. Once we started getting things like accelerometers on chips, they embraced it and released the Wii. And this was a really simple system, not a lot of storage. We're talking about CD-ROM there, but they keep it simple and they take half the market share. So Sony and Xbox, Microsoft, they're competing and they're losing a lot of market share to Nintendo. Getting into the 2010s, it's a lot more of the same. Around 2015, I got pulled into a project trying to make a cartridge-based system. We solved a lot of technological problems, couldn't get over some sociological hurdles. There was clearly demand for it. We just couldn't get the money for it. But it was interesting to note that at the same time we were working on that, we saw patents coming out being issued to Nintendo for something that eventually became the Nintendo Switch. So Nintendo, they're still using a lot of ROMs. Chip companies, they wouldn't want to talk to me as this small developer. They would talk to Microsoft and Nintendo, but I was trying to buy ROMs, and that was really, really hard. One thing I did manage to do is to solve some of my storage needs, found micro drives, leftover new stock from the iPods, still available in the channel. I could get a few of those to get past a certain hurdle, but I just needed ROM. So one of the things that history really teaches us here is that the costs of developing for new media are really, really expensive. So this is going through my memory of what I saw. The Super Nintendo programming tool. First time I ever saw these, I saw a couple of them in a back room over at Activision when I was working there. Those things, in 1990, they cost the company $60,000 per unit. Needed one of those for every single programmer on your project. So that was really cost prohibitive. They came out with a cost-reduced version, only $15,000. This was really, really hard to deal with, a tough nut to swallow as a small developer. And that's really where I started earning my money and trying to create emulation tools, ROM emulation for the Super Nintendo. CD-ROM mastering tools. In 1991, $25,000 is what this box of disks cost us. A box of hard disks so that we could master Windows with multimedia extensions. The first edition of Windows out on CD-ROM. That was a real pain and of course a huge expense. Then a few years later, at that little video game company I helped co-found, we had the opportunity to create games for this new game system that was coming out, the Nintendo 64. And of course, all that's developed by Silicon Graphics. Their development solution for that is to ship us a computer that is console height, 19-inch rack, real deep, needs its own dedicated 20-amp breaker. $100,000 per unit. And again, this is one of these for every single programmer on that project. And fortunately, we managed to swing a deal with Nintendo, so pretty much all I had to do was just get the building wired for each one of these machines. One of the things that we learned is network-based delivery hasn't been keeping up with the traditionally distributed media. And this is something I started tracking around 2006 when I was working on the Blu-ray drive for Sony. So here we're starting off, again, on a logarithmic scale. We've got about 1 kilobyte of memory on each cartridge for those early games. And you can see Atari, they're chugging along, not really keeping up with the market. They're trying to leverage a lot of that old technology. Finally here in the 1990s, we're getting to their last system, the Jaguar, and it's playing catch up at this point. One of the things that's kind of fun and interesting here is you take a look at the Sega Master System, and they're growing, getting into the Genesis, the Saturn, and the Dreamcast. And they're not quite keeping up, so they kind of went away. The interesting thing about computers is they were chugging along. We get into this magneto-optical territory on the next computer that was a little bit delayed. So had it released on time, that would have followed the curve nicely, but it was a little bit delayed. And then we get on up here, and ultimately we're just converging with the Sony systems. Everybody's using Blu-ray here, or one of the other optical media drives. One of the key ideas I want to give here is if we can get more memory, we get more game. More game allows us to engage with our customer for longer. And ultimately, customers are judging us on hours of entertainment per dollar spent. So if we can give them some more game, engage them for a little bit longer, we're doing a lot better, and we're able to sell those games a lot easier. One of the things that's been really tough for us in the industry is if we're using ROM, say semiconductor ROM or CD-ROM, we really need to be able to emulate this in place, in situ. And that is my quick history of video games. Any questions? Start discussion? Yes, sir.
Retro games coming back, the retro consoles, which seem to be just as popular as throwback
That's a very good question, and the question is about retro gaming and the use of Raspberry Pis. What's my take on retro gaming? So actually in 2015, my challenge was to create a cartridge-based gaming system to meet the needs of the retro market. There was clearly an interest there. Unfortunately, we did not do as well as we wanted to on our crowdfunding campaigns. Most of that, I would admit, is due to mismanagement. I think there's a lot of potential there. Our team just wasn't strong enough to make it happen then. Interestingly enough, a few years earlier, about 2010, 2011, Sony hired me on because I had, in 94 and 95, really taken the the Sega, oh goodness, I've taken apart so many game systems. It was the Sony PlayStation I took apart and really disassembled, even pulled the system ROM, wrote a disassembler, disassembled their system ROM, and so in 2010, Sony PlayStation Americas comes up to me and says, we want to break into the Brazilian market, which has such high import tariffs that it's been impractical to get an official brand presence. And so in that particular case, here we are 15 years later, and we're talking about using the same technology. Sony definitely wanted to reuse a lot of the software base they had, but they wanted to be able to package that into something that could be assembled in Brazil. So there are markets, especially when you look worldwide. Brazil is a great market. They definitely have manufacturing partners willing to work with us. They've got low import tariffs on the components. So if we're building chips in the US or Japan or China, we're able to get those into Brazil very cheaply, and we're able to get a lot more life out of some of those systems that today we consider retro gaming systems. Anyone else?
Okay, so I've got a question because
Sir.
you mostly said about like media that you need to bring data to customers, and if I think about industry like creating movies, there is also a huge need for storage, like primary storage for creating very quickly 3D models of the whole scene, and also you need a lot of storage to keep data, for example, historical data, like from previous movies you created. You need to keep that stuff. So you need a bunch of servers that are keeping the storage. And do you think that there are some like unexpected challenges in game industry that are related to like having a lot of storage if you are a company which creates games?
There are definitely a lot of challenges. One of the biggest challenges that we've been facing in recent years is trying to preserve the early development copies of early video games. The film industry, they've been dealing with similar issues on their earlier films. Especially when you take a look at the early films that were on nitrate prints. These are apt to fade, so they try and put these in vaults. In the case of video games, we have a lot of early copies of games that were stored on EEPROM and are now suffering what we call bit rot. So a lot of the bits, they're just dropping out, and it's very hard for us to go back and try and preserve these. On the more modern development, we certainly need to be able to create a lot of output. We create a lot of data. Fortunately for us, when we're creating the 3D models, the models themselves are relatively small until we do the rendering, and once rendered, that final product is something that we can store. Of course, that compresses down through video compression. MPEG has been wonderful for us. One of the challenges that we faced when going from ROM cartridges to, say, optical drives, was really interesting because we didn't have the bandwidth to load a lot of data from the disk into RAM right away. So we had to create interstitial videos, something that we could play, load up a few frames at a time while really loading data from the other part of the disk into the machine so we could play the next level. So a lot of the time we're playing a little bit of canned audio, a little bit of canned video, just to hide the fact that we need that bandwidth to get more data off of the disk. When it comes to storing these videos, we need a lot of disk, and it's just getting more and more. Does that answer your question? Yeah. Okay, thanks. Anyone else like to talk about video games? Yes, sir.
You mentioned that the worldwide game industry size is 134 billion US dollars, right?
Yes, sir.
And I'm wondering if the number, including the investment by game vendor for development system and network size like a Nintendo network, or just the consumer side.
Okay, so the numbers that I showed here for the video game industry size here, let's see if I can go to the top. So here we're talking about really the money that's spent by consumers worldwide. And the question, would you repeat the question again, sir?
Okay, so I'm wondering if the number, including the investment by the game vendor, like a development system or network size, like a Nintendo network.
Oh, okay. So we're talking about the relative size of the investment by the developer versus the worldwide sales. So clearly, we were willing to spend huge sums of money to get into the newer media as they were coming out. I think that when we're talking about game publishers like Nintendo, Electronic Arts is an independent publisher. We wound up selling our little company off to a company called Acclaim Entertainment that was the primary competitor of Electronic Arts for many, many years. But publishers are looking at the number of sales, and they're able to amortize the cost of these development systems over these larger sales. The problem with having a very expensive development system for new media is that you really exclude a lot of the smaller and the upcoming developers. So it's really hard to embrace those, and that's actually one of the things that has allowed the industry to shift a lot from these traditional distribution systems to more mobile games. So with mobile games, we're able to get people started developing mobile games at very little investment. They buy a phone, they've probably already got a phone or two kicking around, and they've probably already got a PC. Now they just need a small development investment, and they can get started and rocking and rolling. And we've actually seen a lot of the gaming going toward the mobile platforms these days, but that also seems related to the experience tapering off. So the reason people used to go to arcades, even after we had home game systems out, was that arcades allowed other experiences that you couldn't have at home because they had specialized controllers. You sit down in this driving game or some flying game. We had Laserdisc-based games that would be prohibitively expensive to have at home, but for a few quarters you could go to an arcade and play these things. So there's still an arcade market, even though the trend is certainly dying down a bit and has been since about the 1990s. But it's still going strong, and there's certainly some opportunity there if we could give the arcade players something that would be very difficult or prohibitively expensive to have at home. And that comes down to economics for the arcade operators or the route operators. So if you give them a machine that they can buy for, say, a few $1,000s, and you can demonstrate that they can expect a good return on that investment, those arcade operators are going to keep buying those games. Any other questions? Yes, sir, in the back.
It seems like there's a clear storage requirement difference between somebody developing on mobile versus a console or PC. But there's still a really active PC gaming market. Is there any fundamental difference between
Well, we've certainly seen the question was if there's a fundamental difference between storage expectations on the console side versus the PC gaming side. In the 2000s and the 2010s, we've seen a lot of convergence between the PC gaming and the console gaming markets. Console games are a lot easier for most people to plug in. There are fewer variables. PC gaming, especially in the earlier days, were very difficult for us developers because we had to develop and test games for all these most likely combinations of hardware. We're talking about different amounts of RAM, different CPU, a different audio card, a different video card. From a developer perspective, we much prefer to give the console experience because we have a lot less testing and a lot fewer combinations that we need to test for. Of course, the storage expectation seems to be about the same because right now you can buy a hard disk for a PlayStation 4 or a PC, and there we're looking at roughly the same amount of storage available. If we could offer a console-based machine with a larger distribution medium, then I think we'd have a very different market. And back in 2015, one of the things I was trying to do was introduce a cartridge that could store various different widths of data as well as various different capacities. So in the cartridge capacity chart that I had here, there it is. So in this cartridge capacity chart, you can see 2015, we're leveled off at about 100 gigabytes there. And I was creating a cartridge that had a spec of 4 terabytes. And that was the addressable size using the 32-bit DMA mode on that particular cartridge. That would have opened up some doors, but buying that much storage was still cost prohibitive at the time. Does that answer your question, sir? Okay, thank you. Any more? Yes, sir, in the back. Yeah.
So the cutscene structure that games had, you said, early on, that was because you needed to load stuff. Is that really still the reason they do that? Because like in Destiny, this is where you get your big name actors and your expository lumps, and this is where your villains monologue. How can you have a story here?
Yeah. So the question was about the cutscenes and if that is really necessary. And sadly, I'm revealing a little bit of the magic of the video games right now, and that is that yes, most of the time when we're playing you one of these interstitial videos or a cutscene, we're giving you a little bit of the story. But what we're doing is we're hiding some of the technical limitations of the machine. So we have to load, say, from optical disk, from hard disk. We've got to shovel that data into RAM.
But Zelda doesn't do this. Zelda on the Switch, you can just wander around and shoot things all day. There's never any floating, spinning thing unless you teleport.
Oh, okay. Yeah, I think with Zelda there's a slightly different game architecture and a slightly different game mechanic. But in general, I think that it's going to be the case. When you see a cutscene, you have to wonder a little bit about what is going on behind the scenes. If you're playing on a PC or a console that, say, has a disk activity light, you can probably see what's going on behind the scenes just by watching the disk activity. Yes, sir.
So what are your thinking on the cloud gaming side, particularly storage, where the game will be streamed to console? On the console, let's say your phone, it can be mostly, if it's transient data, not necessarily persistent, you have to be persistent anyway. And you have your state store on the CSV side.
Yeah.
And CSV is not necessarily thinking about the cache kind of storage media, but it can be just like a x86 storage system.
Yeah. So the question here is about streaming games to mobile devices, and in that particular case, I think we're going to see a little bit of the cutscene strategy. We can buffer up some video, especially if it's highly compressed, something that might have something that we can render a little bit on the on the device itself. So right now we're able to have a pretty good rendering in real time, so we can go ahead and just upload a lot of 3D models, and that allows us to move a lot less data in advance. So while we're playing some real-time rendering, we can also stream a whole lot more of the game and hide the fact that what we're really doing is streaming while we're showing you this cute little movie. Does that answer your question, sir? Okay. Yes, sir, up front.
Yeah, I have a question related to the previous question. So given the kind of cartridge system also need a big amount of storage, so is there any a trainer style to add a network access to the cartridge system and just get the cloud storage rather than have the physical?
Yeah, so the question is about using a cartridge-based system and networking. One of the things that is really tough about streaming content or network-delivered content is that we're asking the end consumer to buy that amount of storage up front and to really buy that shopping bag before they fill it. And so it can be a hard sell for some consumers. We can upgrade. Ideally, I hate to tell somebody, hey, if you buy a 200 gigabyte hard disk, you have to replace it because you've only got one hole for a hard disk. Ultimately, what I'd like to see is the ability to just chain on and add on disks so they can buy these a la carte. So that gets our cost of entry for the system way down. We saw this with the PlayStation. The trick there was in getting the cost of entry down to that $300 price point. Before then, we'd also had a bunch of other systems trying to introduce CD-ROM-based games. We had Commodore even trying to jump into the game industry by repackaging an Amiga 500 computer. They put it in a black box and they called it the CD-TV. They were charging about $800 for that unit. We also had a Philips CDI about the same time. Again, the price point was very high. 3DO, that was a bunch of people left Electronic Arts, tried to create this device, and the price point was just prohibitive for people. So what we have to focus on is maintaining a low cost of entry to get them in. We don't want to have to make them buy a lot of storage up front. And again, the game that we were playing back in those days was razors and razor blades. We could afford to sell the base system a little bit below cost because we're making our margins on the games themselves, and the games themselves carried the storage with them. Yeah, so yeah, it's a hard sell just telling people you need to buy this big blank empty box. Anyone else? Sir?
What's your take on cloud gaming, like PlayStation Now or Google Stadia?
I have some very mixed feelings on cloud gaming. So the cloud gaming is ultimately only as good as your network connection. Right now, in some areas of the United States, it's hard to get that network connection. It's still difficult. Yeah, even in the local area, once we get, say, 15 to 20 minutes outside of Silicon Valley, there are people who cannot get cable modems, DSL. The service just isn't carried by the local carriers, and so they have to rely on things like satellite-based internet, which is prohibitively expensive. It can have some good download speeds, but the uplink speed on those is very, very slow, and it's got a tremendous amount of latency too. So you really can't play a network multiplayer game via satellite because you're looking at latencies of probably at least half a second, maybe more. So for having a cloud-based game, it makes sense for people in highly networked metropolitan areas, but once you get out into the rest of the country and the rest of the world, it gets very, very difficult just because the network infrastructure isn't there, or at least isn't there yet. So we want to make sure that we get some games that we can distribute and really reach those other people who want to spend money, and they're hungry for entertainment out there. Anyone else? Question? Sir?
So you had mentioned, building a 4 terabyte, cartridge, right? Is that needed? I mean, what do you need on that stage?
Okay. The question is why do we need a 4 terabyte cartridge? And the answer is ultimately with developer greed. The publishers hate the developers because developers always want to fill more cartridge, more storage. When I was working on the Super Nintendo games, I created a development station and turned to my bosses and said, "Hey, I can make this thing. It's got 2 megabytes that we can emulate on here. Will we ever need to do anything more than 2 megabytes?" And they say, "Oh no, we'll never need to do any more than 2 megabytes." So the design wasn't even done yet, and I had to start saddling a couple more parts on there to get us up to a 3 megabyte cartridge, and ultimately I revved the board, and we were up to a very tight surface mount 4 megabyte cartridge. So there we're going from megabytes to terabytes. So the need is there. If we can offer a game that has terabytes instead of gigabytes, people are going to buy these games. If we can offer it at a fair price, it doesn't have to be a good price. As long as it's a fair price, there are going to be people out there who are bragging to their friends saying, "Hey, I got this exclusive new games." People are willing to spend $80, $100 or more for a single game. It's crazy. And once they've got that game, other people covet that game, and it's a real social interaction that helps us sell games. It's a little nuts, but it helps pay my checks, so I'm not going to complain.
I just a comment on that.
Yes, sir.
I mean, racing simulators, when you're mapping the track down to a centimeter, you're flying the track, and I was a race car engineer for many years. We could put people in simulators, and they're going, "Damn, this is like better than driving it. When you hit the bump, you move over," and we were spending a lot of money to map tracks all over the world.
Yeah, that's some great insight. Yeah, talking about the granularity that we're able to get in the game. So yeah, the more data we're able to store on that cartridge and deliver to that end user, that gives us a more immersive experience that we're able to sell, and that's why people want to buy these games. They're looking for something that's not just immersive, but it's engaging, and a lot of the reason they're buying this is because it's novel. In entertainment, people are looking for novelty. We could put anything we wanted on that cartridge, and just because it's new, it's going to sell.
One other example on that is like motion games like FIFA or any of the sports games. The more resolution you've got, you can get past the uncanny valley problem, and it looks like humans playing at speed, and you get all the details of the shirt rippling in the hair and stuff like that.
Yeah. So
yes. Some of that is processing, but some of it.
Yeah, and a lot of it is processed on the system itself, but a lot of it is pre-processed and stored. Sir.
With current cartridges, you're calling them cartridges, but basically the things that's storing the drive or storing the device. What is being used right now? Is it Blu-rays mostly what's being used?
So sadly, since about 2006, a lot of it is Blu-ray disc. Sony spent a lot of money. When I was an employee over at Sony PlayStation, the company had lost, I think it was, $674 million that year. But the president said, "But that's okay because we won the format war. HD DVD is dead, Blu-ray is king." And at the time, I thought that was incredibly foolish, but history has certainly proved me wrong. Winning that format war has been a tremendous gain for Sony, just running HD DVD out. So the systems that are being developed and distributed these days include the Nintendo Switch. And Nintendo kind of surprised us back in 2015 by patenting a cartridge-based system. Sadly, the cartridges themselves perform about as well as a micro SD card. I don't want to knock micro SD cards, but for general purpose computing, it's a wonderful interface. But for video games, we can do a lot more because the console manufacturers are able to specify their own proprietary connectors, their own proprietary interfaces, and we can do more.
What type, on the Switch, you said it uses a cartridge, what type of actual storage?
It's a flash cartridge. They have flash cartridges. I should also add they have ROM cartridges. So in the 1990s, when Nintendo was coming out with the Super Nintendo, or sorry, not the Super Nintendo, it was the Nintendo 64, the one after that. They contracted with Silicon Graphics to do most of the processing on there, but they were also contracting with just about every stacked die semiconductor storage company there was. I think there were 3 or 4 major ones, and Nintendo had, I think they contracted with 3 of the 4. Unfortunately, it didn't come to fruition fast enough, and that limited the size of the cartridges that were distributed for the Nintendo 64. Sir, in the back.
Just another quick question. I'm going to use the SNK Neo Geo as an example. Like, I know ROM cartridges are very quick. SNK Neo Geo, if anyone's not familiar, was an arcade system that also had a home release. They pushed it for home release.
And the cartridges were this big.
I think it maxed out around 90 megabytes, 716 megabits, as I recall. But they would run around $200, $300, $400 a pop. So I'm going to use that as an example. They couldn't achieve mass market penetration like that. So the form factor, the size, the cost, even if it had an arcade perfect label that everyone wanted. So would it work now? Is there a way to make that work now? And what would be the value proposition for cartridges in the market now? You know, if arcades were the go-to, the gold standard back then, what would it be now? Would it be speed? Would it be cost?
Yeah. So the SNK Neo Geo, that was a really interesting case, and the idea was it had a lot of merit. The idea was that you could have a cartridge in the arcade machine, and you could sell that same cartridge to the home user and get that exact same home experience. What we've done historically in video games is a lot of the times when we make a home version of a game, we're creating a new copy from scratch. We're trying to just make something that looks as close as we can get to the arcade version. And that said, I've got to apologize for Atari's Pac-Man game. That was something that some programmer said, well, here's a proof of concept, and the publisher said, ship it. And so with this Ms. Pac-Man game that came a few years later, you saw the machine could definitely do a better job if the programmer had done a better job. But getting back to the question, can we release an arcade cartridge, something that would also play in the home? Yes and no. I think it would be a very limited market because with the arcade package, you get the whole arcade experience. You get the different controllers in front of you, maybe a slightly different display, maybe a little bit different display technology than you would normally purchase in the home. And of course, you get a different experience in the arcade as well. With a crowded arcade, you have other people that you can interact with as well. I'm afraid that's it for me. We're out of time, and I wanted to thank you all for coming. So